Hello everyone, welcome to the lecture on Model 5 circuit breaker. Last time we had seen what exactly is a circuit breaker. So circuit breaker is a piece of equipment which can break or make the circuit under normal condition or under abnormal condition. And can break a circuit automatically under fault condition also. So the function of a circuit breaker is to isolate the faulty part of a power system in case of an abnormal condition such as a fault. Now let's see what exactly do you mean by arc voltage. So the arc voltage is the voltage which is across the contacts of a circuit breaker when the arc persists is called as arc voltage. The fault current or the short circuit current is in phase with the arc voltage. So this is the fault current and this is the arc voltage. Both are in phase with each other. So they behave as in purely resistive. The magnitude of the arc voltage is very low, typically around 3% of the rated voltage. Restriking voltage and recovery voltage. So whenever there is a fault occurring in the circuit breaker, what happens is that the contacts get open. So while opening up the contacts, there is an arc formed between these two contacts. Now, how do we extinguish that arc? We can extinguish the arc by using some medium, insulating medium such as air, vacuum, or it can be a gas such as sulfur hexafluoride, or you can use a vacuum circuit breaker. So by these insulating medium, we can extinguish the arc. But it has some property wherein the arc is going to extinguish at a certain point wherein the current has reached to a 0 point. The current reaches at 0. So at current instant 0, the arc is going to extinguish. So the transient voltage which appears across the breaker contacts at the instant of arc being extinguished is called as restriking voltage. So at the instant of arc which is going to extinguish, there will be some transient voltage going to appear across the breaker contact. That is called as restriking voltage. And the power frequency RMS voltage which appears across the breaker contact after the arc which is finally quenched and the transient oscillation dies off, that is called as recovery voltage. So, from at the point of zero current, there will be a transient voltage which is going to appear across the breaker contact, that is called as restriking voltage. Once this arc is finally quenched and the transient oscillation dies out, that part is called as a recovery voltage. So the same definition. So let's look at try to recap what exactly is arc phenomena. So during the arcing period, the current flowing between the contact depends upon the resistance. So the greater resistance, smaller the current that flows between the contacts. So how does this arc resistance depends upon? So the very first point is the degree of ionization. So the arc resistance is going to increase with the decrease in number of ionized particles between the contacts. So once the contacts are opened up, there are some ions and electrons are going to form between the two contacts. So if we increase the arc resistance, then there will be a decrease in the number of ionized particles between the contact. Second one is the length of arc. If we increase the arc resistance, then the length of the arc is going to decrease. So arc resistance is going to increase with the length of arc. Cross section of the arc. So the arc resistance increases with the decrease in the cross section of the arc. Now what are the methods of arc extinction? First one is the high resistance method, wherein the arc resistance is going to increase with time so that the current is reduced and finally arc is interrupted. Now there are various methods or various ways in which the arc resistance can be increased is by using or by increasing the or lengthening the arc. So here the resistance of the arc is directly proportional to its length. As we have seen, the formula R is proportional to rho L by A, where the resistance is directly proportional to the length. If the length of the arc can be increased by increasing the gap between the contacts, that is the possibility by using lengthening the arc. Next is cooling of arc. Cooling helps in deionization of the medium which is present between the contacts, which again increases the arc resistance. Next is reducing the cross section of the arc. The cross section of the arc can be reduced by letting the arc to pass through some narrow opening or having smaller area of contact. Next possibility is splitting of arc. So the resistance of the arc can be also increased by splitting the arc into number of smaller arc in series. So the arc may be split by introducing some conducting plates between the contacts. The last one is suitable. It is suitable for this method, that is the high resistance method is suitable for AC and DC current for lower power circuits. Now we'll be looking at current zero interruption method, which is a second method of arc extinction. The very first was the high resistance method. The second one is the current zero interruption. So this method is employed for arc extinction in AC circuit only. In this method, the arc resistance is kept low until the current is zero, where the arc extinguishes naturally and it is prevented from restriking in spite of the rising voltage across the contact. So the arc can be extinguished only at when the current reaches at zero instant. So in order to explain the current zero interruption, we have two methods or two theories to explain. So the very first one is the recovery rate, or which is also called as Slapian's theory. And the second one is energy balance or Cassie's theory. So this is the recovery rate or the Slapian's theory figure, wherein the arc is going to extinguish when the dielectric strength is greater than the restriking voltage. Here, arc is not going to extinguish when the restriking voltage is going to be greater than the dielectric strength of the medium. Now, in case of energy balance theory, here the arc is finally extinguished. So the power becomes zero and the gap is fully deionized between the contacts and the resistance is infinitely high. So first the power is going to increase here. It reaches a maximum value, then it's going to decrease and finally reaches a zero value as seen in the figure. So if the rate of removal of heat is faster than the rate of heat generation, then the arc is extinguished. If the rate of heat generation is more than the rate of heat dissipation, then the breakdown again results in an arc for another half cycle. So again, these two concepts, the high resistance method and the current zero interruption, is very important for your exams. Next part is the current chopping in the circuit breaker. So current chopping in a circuit breaker is defined as a phenomena in which the current is forcibly interrupted before it reaches the natural current zero. So there is a chance where the current has not to be the arc has not to be extinguished at the instant zero itself. There are chances that the current is already or the arc is already extinguished before it reaches the current zero. So the current chopping is mainly observed in vacuum circuit breaker and an air circuit breaker. So there is no such phenomena in an oil circuit breaker when you compare with the vacuum circuit breaker and the air blast circuit breaker. So the current chopping is predominant while switching the shunt reactor or the unloaded transformer. So this is where the current chopping phenomena comes into the switching shunt reactor or the unloaded transformer. So generally what we have seen is that the arc is going to extinguish in a circuit breaker at a natural current zero only. This means that the arc extinction capability of a breaker will always ensure that it is going to extinguish at a natural current zero only. Let's assume we are taking air blast circuit breaker. In this case, when the breaker is used to break the circuit breaker of an unloaded transformer or the shunt reactor, then the current will be brought to zero well before the natural current zero. Why we are taking an example of air circuit breaker here? Because the current chopping is predominant. It is very predominating in while switching the shunt reactor or the unloaded transformer, and it is observed usually in a vacuum circuit breaker or an air circuit breaker, right? So this is because the breaker is interrupting only the magnetizing current, which is very less compared to the full load current or the fault current. So the magnetizing current which is produced by the unloaded transformer, which is very small compared to the full load current or the fault current which is going to occur. So as the capability of the breaker arc extension is very high enough, therefore a low magnetizing current will be brought to zero before the natural current zero position. So this phenomena is called as current chopping. So now to understand, let's take a circuit wherein the resistance, the inductance and the capacitance are connected in parallel with respect to an circuit breaker, where L is the inductance of shunt reactor, C is the capacitance of winding, R is the eddy current loss in the reactor. So breaker in this figure is an air blast circuit breaker. Now consider a shunt reactor as shown in the figure. So let us consider the magnetizing current is flowing of very low magnitude, right? So the current which is there, that is the magnetizing current, is of very low magnitude. Now what happens under the normal condition? So the current which is going to flow through the reactor, say the current I, is going to store its energy in the form of magnetic energy in an equation form of 1 by 2 Li square. But as soon as the breaker is open, right, the current chopping will take place and the current through the reactor becomes zero. Due to this sudden drop of current through the inductor, a high voltage will be developed across the inductor now. Therefore, the voltage across the capacitor will also increase as they are connected in parallel. So when the current becomes zero, obviously there will be a high voltage across the inductor. So if the voltage across the inductor increases, hence the voltage across the capacitor also increases. So VL, that is the voltage across the inductor, is greater than the voltage across the capacitor. So both are going to increase. If VL is going to increase, then VC also increases simultaneously. So the energy stored in the inductor is transferred to the capacitor now. It means that the energy stored in the form is electromagnetic charge is now transferred to the capacitance in the form of electrostatic form. Therefore, 1 by 2 Li square is equal to 1 by CV square. So where V is the voltage across the capacitor. So after equating, we get V is equal to 1 by root 2 of L by C. So this is the equation what we find by equating these two equations. So this is how the current chopping concept takes place. Now the next topic is the interruption of capacitor current. So here what we can see is that there is an electric circuit of simple power system network, right, and we have inductance in series with wherein the capacitance is in parallel with the source, inductance is in series. We have a circuit breaker over here. So the inductance capacitance will have a voltage VC. So this is voltage across the resistance of the contact, right? Now, so how the capacitor current is interrupted? When the circuit breaker contacts are opened. So when we have unloaded long transmission line or a capacitor bank and a circuit breaker in association with it. So when the circuit breaker opens, the unloaded long transmission line or the capacitor bank will be carrying a current that's get interrupted. So if the capacitor current is interrupted, and then when we know that a very high voltage transient will be developed across the circuit breaker contacts. So this is a simple circuit of power system where C represents the stray capacitance, CL represents the line capacitance. Here, the value of CL is greater than C. So when the contacts of the circuit breaker are closed, then the current flowing from the supply will charge the line capacitance to its maximum voltage. So this is your line capacitance. So when the contacts of circuit breaker are closed, if it is closed, then the line capacitance is going to charge to a maximum voltage. And if the contacts are open now, so there is no current flowing through the voltage uh, through the line capacitance. So the line capacitance voltage will be 0. So the voltage across circuit breaker will be what? It is Vc minus Vr minus Vcl equal to 0. Therefore, we get as Vr is equal to Vc minus Vcl will be the voltage across the circuit breaker now. So this is the explanation again. So it is observed that when the current reaches 0 at instant A, the voltage is maximum at M. This happens when the circuit breaker contacts are open. So at instant M, the capacitive current is 0, system voltage is maximum. Now if the interruption occurs, then the capacitor CL, that is the line capacitance, remains charged at maximum value of system voltage, that is M. And after the instant M, the voltage across the breaker gap in the difference of Vc and Vcl. So the voltage across the circuit breaker will be the difference of the stray capacitance voltage and the line capacitance voltage. Now at the instant N, the voltage across the gap is twice the maximum value of the stray capacitance voltage, that is Vc. If the breaker restrikes, now the voltage across the gap becomes partially zero. Therefore, the voltage falls from 2 volt, that is 2 Vc, to 0. So because of that, a severe high frequency oscillation is going to occur and the current is interrupted again. So the line capacitance at the voltage is negative of 3 V max. So at the instant P, the system voltage reaches its positive maximum value at T. So the voltage across the gap becomes 4 now, 3, 4. So the capacitor current reaches 0 again and there may be an interruption. So the transient voltage oscillates between minus 3 am to plus 5 max, that is between point P and Q. Thus the voltage across the gap goes on increasing. So again the same explanation here. So now we'll be looking at the classification of circuit breakers. So the classification of circuit breaker is based on the voltages now. So the first one is the low voltage circuit breaker, which is less than 1 kV, medium voltage circuit breaker, which is 1 kV to 52 kV, high voltage circuit breaker, which is 66 kV to 220 kV. Next we have extra high voltage circuit breaker, which is from 300 kV to 765 kV, and above 765 kV it is called as ultra high voltage circuit breaker. Now classification based on the location, it is indoor type and outdoor type. Classification based on the external design, it is dead tank type, or the second one is the live tank type. Now the classification based on the medium used for arc quenching, this is very important. So the classification of circuit breaker based on the medium, that is the insulating medium which is used for the quenching of arc or arc quenching. The very first one is the air circuit breaker, oil circuit breaker, air blast circuit breaker, sulfur hexafluoride, that is SF6 circuit breaker, and vacuum circuit breaker. So most of the substations and the power stations, they'll be using SF6 circuit breaker as an to interrupt the fault. So first we'll be looking at the air breaker air brake circuit breaker. So the air circuit breaker has several advantages when compared to an oil as in quenching medium. Why? Because it eliminates the fire risk if air is used. When we look at the maintenance associated with the use of an oil for arc quenching, which can lead to a fire. Second is the absence of mechanical stress when we use an air brake circuit breaker. That is set up by the gas pressure and the oil movement. The third is the elimination of the cost of regular oil replacement that arises due to the deterioration of the oil with the successive braking operation. So these are the three important advantages over the oil circuit breaker if you use as air as a medium for circuit breaker. So this is the circuit breaker, air circuit breaker picture over here. So these are the moving contacts. These are the arcing contacts. These are the arc runner, arc plates, and the whole part is called arc chute. So here it is the same kind of picture, but in different way. So the air brake circuit breaker uses atmospheric pressure air as an air quenching medium over here. As the name itself is air brake circuit breaker. So air is an arc quenching medium. So this type of circuit breaker employs a high resistance interruption method. So we have seen methods of arc extinction. We have two methods. One is the arc resistance interruption method, and the second is the current zero interruption method. So in high resistance interruption method, we have many methods. One is you can increase the arc resistance by lengthening the arc, cooling the arc, reducing the cross section area of the arc by splitting the arc. Right. So here in this arc brake method it employs an arc resistance interruption method or a principle to quench the arc. So the arc runner and the arc chute increases the length of the arc. Moreover, by cooling and splitting the technique, arc resistance increases to such an extent that the voltage drop across the arc and becomes more than the supply voltage. This will extinguish the arc at the current zero. So the breaker has two contacts. One is the main contact and the other one is the arc contact and main contact. The main contacts are silver plated and they have low contact resistance. The current conduct when the main contacts are in closed position. So the current is going to conduct when the main contacts are in closed position. And the arcing contacts are made up of copper alloy and they are of heat resistant. Now we'll be looking at the working. So when the breaker is in a closed condition, the current flows in the main contact. So when the contacts are closed, current flows in. So as we see, we have looked at the picture over here, the figure for air brake circuit breaker. So when the contacts of the breaker is closed, so current flows in the main contact, and when the contacts are opened, the main contact is separated first, and the arcing contacts are remain closed. So here, during the fault occurring, the main contacts are going to open, the arc contact remains closed. Therefore, the current in the main contact moves towards the arcing contact. Now the arcing contacts are going to separate and an arc is formed between them. So here the arc resistance is used for arc interruption. So the lengthening, the splitting and the cooling of the arc increases the resistance. So the two chambers called as arc runner, which are also called as arc horns, and the arc chutes increases the length of the arc. Therefore, the arc moves along the arc runner and forced to move upward into the arc chute. Therefore, the arc is split in this way by using arc splitter, and thus the arc is extinguished. So the low and medium voltage system uses ACB in electric furnaces and in large motor. They are available in the range of 400 volt to 12 kV. We'll discuss the further circuit breakers in the next class. Thank you.